Right, so let's move to example 50. Guys, the road OA rotates. It's very easy. This example is very easy, and you can directly solve it from the equations that you have in cylindrical coordinates that are these equations. So you can directly solve it using this equation, or you can also use the derivation from its beginning. All right, so it's up. So the question is that I have here a road OA rotating counterclockwise with a constant angular velocity. So I know that theta dot is constant. And what does this mean? If theta dot is constant, then this means what, guys? Theta W prime is what? Is 0, all right? So this will help me if I want to find the acceleration, in fact. But here the question is to find the speed. Two pin connected slider blocks located at B move freely on OA so that R is equal to 102 minus cosine theta. So this is the equation of R, and I need to determine the speed of the slider blocks at theta is equal to 120. So I need to find this V, guys. This V, and then I can find the speed. Now, what is V? Or you can also find the speed directly, right? So you can also find the speed as R dot squared plus R theta dot squared, all right? Now, I know, guys, that this is a 2D problem, which means that this term is 0, so I only have R dot to find, and only R dot to find because theta dot is constant and it is 5, right? So since R is equal to 100, 2 minus cosine dot. So what will be R dot, guys? R dot will be 100 sine theta dot. Do not substitute theta here, guys. Do not substitute theta here by 120 and then do the derivation. Theta is a variable, so you should do the derivation before substituting, right? So this is R dot. If I want to also find the acceleration, then this means that I'm going to find R double dot, and in this case you're gonna see that you will have theta double dot, and theta double dot is 0, all right? So this is theta dot, in fact, all right? So now I know that VP directly is equal to R dot, which is 100 sine theta dot UR plus R, which is 100 2 minus cosine theta U theta. Do I miss something? Yes, I missed theta dot. Now, guys, you can replace. Right now, you can replace theta dot by 5 and theta by 120. And then you can find V as the radical of this squared plus this squared, the components in R squared plus the components in theta squared. Or, guys, you can start from R. So you can say that R vector is equal to RUR since I don't have any Z here, right? And then you replace this R by 102 minus cosine theta. And then you do the derivation. And don't forget that if you want to do the derivation, you have DUR over DT. You're going to have the same answer. Because, in fact, this derivation is coming from the derivation of this equation. All right? So you can do it, guys, from the beginning, as you did in your assignment. You can replace R by 102 minus cosine theta. And then you can do the derivation using the chain rule and so on. All right? So it's very easy. Example 15. I'm going to